morning, students. Welcome to another beautiful lesson in Algebra 2. Today we're going to be talking about a real-world problem using our ideas of polynomial factoring. And so what I have here on the screen is a rectangular box. So this is actually a part of what you're going to be doing for this week. As a small task, I want you to find somewhere in your home a rectangular box. So it doesn't have to have these dimensions. It can be like more slender, like a DVD case, or it can be a bigger box, like those wooden boxes that you get for like packing up stuff. Anything, just find a rectangular box and submit a photo to me. Just so I know that you kind of did our little task of finding a rectangular box. But the purpose of this, we're going to be using it to go through a real world problem of trying to find the dimensions here. So we have our side here. So remember, when you're looking at a box, you have a length, a width, and a height. So let's just say if we're looking at it this way, the side that goes across here is going to be our length. And then the side that goes up here is going to be our height. So if we're sitting it down like this, it's going to be this high, however long this is. This is our length. And then if we're facing it down here where the logo is, we'll have this edge here. We'll call that our width. So in this case, let's say we know some given length for our width here. So let's say we know that our width is x plus 2. And let's say we also know the total volume here. Like, remember, volume is length times width times height. So if we were to multiply all that together, let's say that was going to be, okay, and then let's say we also know the volume, and let's say the volume is x squared plus 4x plus 4. So there are ways that we can go about finding at least the surface area of one of the sides around our rectangular box here. So if you know the width, this is going to be this length here once again. So this long length here is what we're going to call our width. And then we know our height is down the side, it's going down, and then our length is going to be across here. So let's try to figure out first, if we were to divide the volume by the width, what parts or dimensions of this box would that give us? So remember that to factor, it means to break this part into sections. And I just realized I wrote this volume incorrectly. I apologize. This should be x cubed plus 6x squared plus 12x plus 8. Okay, so that's our volume. So first, let's do some division. So we can take our x cubed plus 6x squared plus 12x plus 8 and divide by the x plus 2. And so we can solve this to get the remaining polynomial, or the quotients for this. So we can take, remember, we divide first. So we'll take the first term under our little house and then divide by the first term outside. So x cubed divided by x. Remember, we subtract the exponent. So that'll give us the exponent of 2x squared. Then we multiply and distribute this number or a term on top to both terms here. So x squared times x is x cubed. X squared times 2 is 2x squared. Then we're going to subtract. X cubed minus x cubed is 0. 6x squared minus 2x squared is 4x squared. Bring down plus the 12x. Start over, so we divide this first term here by the first term outside. 4x squared divided by x. Well, an x and 1x here cancels out, leaving us with 4, just 1x. Again, we multiply 4x squared, and then 4x times 2 is 8x. Again, we subtract. 4x squared minus 4x squared is 0. 12x minus 8x is 4x. And then lastly, we bring down once more, plus 8. And then divide 4x, the first term here, by the term here. 4x divided by x. The x's cancel out, leaving us with 4. 4 times x is 4x. 4 times 2 is 8. Again, we're going to subtract. And then we're done. We have a remainder of 0. And our quotient is this x squared plus 4x plus 4 here. So what we found is that we took the width, and then we took this part here, which was the volume, and we divided the volume by the width. So what happens is if we think about this in terms of what we're actually looking at, we took this rectangular box that we have here, and we discounted what this length would be here. So we don't care anymore. We divided out this length here. So we only care about the area of this rectangular surface area that we have right here on the side, because we're now disregarding the width. All we care about now is the length here times the height of our rectangular box here. Okay, so essentially what we just found is the area, or the surface area, of this box. So that's what this quotient represents here, the x squared plus 4x plus 4. This represents our surface area. If I consider this like the front side of my rectangular box, the surface area of my front side, or my length times the height. So this would be, in terms of the units, if we're looking at inches, my inches squared. So that's assuming that we're looking at inches. So the width would be inches, the volume would be cubic inches, because this is a cubic function with the exponent of 3. Okay, so here we're just taking what we talked about in relation to polynomial division and using it in order to determine what other dimensions we would find for this particular shape. So I give you a question of the day for this week. That's due tomorrow at 5 p.m. And it just goes over you using this idea to determine the surface area of a given problem. So feel free to either draw out a little box on your paper. So the way I like to do it is I draw a rectangle, and then a little to the left, to the bottom right, I draw another rectangle kind of the same. And then I just connect the bottoms, the sides, bottom. So that's how you can draw out a little rectangle of your own. Or you can do like I did, and this is also a part of your activity, so to speak, for the week. It's to identify a rectangular box somewhere in your home. Again, it doesn't have to have these same dimensions, and just take a photo of it and submit it here in Google Classroom. Alright, I'll talk to you all later. Have a good day.